Thank you for coming out. I'm so happy to be here with you this morning. My name is John Handler. I'm Director of Technology for Search Services at AWS. Joined today by Abhijit from Adobe and Shri from Freshworks. Really looking forward to this and excited to talk with you today. So who's used a search engine ever? Okay, right. So everybody's really used a search engine. And really what a search engine does is it connects you through whatever information goal you have to a big source of information that can solve that goal, whether you want to buy a product, whether you want to find a hotel to stay at, whether you were looking for a research document. You go to a search engine with some information need, and the search engine mediates between you and the information that that search engine works over. And we're all, up until 2 years ago, sort of this is the way that we all interacted with search engines. It was an iterative one-shot methodology where you'd type a little text, you had a text box, you type a little text, maybe you had a faceted search experience where you could click some attributes and values and that would help you narrow in the search. And the search engine was really just matching your words to words that were on the documents to bring them back to you. And of course, core to the search experience and core to search was figuring out how well each of those documents matched the intent that you had when you came to the search engine. So search engines are in the databases world, but where databases give you all of the stuff, search engines try to give you the best stuff. We got very used to this. We have this iterative, lexical-driven kind of search route where I enter some query like blue shoes. The search engine provides me some results, maybe some links, maybe some pictures. And in the best of all worlds, one shot, I get exactly what I wanted, and I'm happy, and I'm done. But really, we're all sort of used to, again, the not getting exactly the right thing. And so taking our query, rethinking, adding a few words, subtracting a few words, and having to sort of iterate through this lexical cycle. Because we're typing words, and the words themselves actually encapsulate meaning. And so a text query like blue shoes, pretty easy to solve. But if I have a query that's more like, I want a cozy place to curl up by the fire, and in my head I'm thinking, oh, I have an 8-foot blue couch, that's going to be a really nice place. All I have is the words cozy place to curl up by the fire, and the search engine is stuck on the words. So the words themselves do incorporate or encapsulate meaning, but there's a broader way of bringing in the meaning that lets me match meaning to meaning. And that's the revolution and the change that's happened over the last really just couple of years. The ways that we interact with information now are really much more meaning-driven than word-driven, or can be, right? So if we think about the search engine, I have a pile of stuff. That's the information that I'm going to feed into the search engine, and the user comes with an information goal. We first code all the stuff and put it into the search engine, and the user comes with the query with some words, some structured information, and perhaps some images now. We can use large language models to code all of this information into a multidimensional vector. And just to demystify a little bit, I'm sure everybody's sort of heard a lot about this stuff, but just to demystify a little bit, a vector is just a large array of floating point numbers that define a multidimensional space. And so I take all of my inputs, I code them into this multidimensional vector space, and the way the large language model learns the dimensions brings together things that are semantically related so that when I run my query, I can generate a vector in that same space and find the things close to it which are related in meaning. Ultimately, the search engine is going to take that vector, match it to the vector of my stuff, and bring me a ranked result, which is a set of documents. So we have the text box interface. Another way that search has been changing, or information retrieval has been changing, is to move towards a more conversational interface, Where we had that one-shot iterative lexical query, we now have systems that are able to bring conversation into the picture so that the time scale of my retrieval is now extended, and I'm having a conversation where things that I've asked for before are fed forward and inform the retrieval. So these are this is the chat interface. The typical thing you do, you take your information, you run it through an LLM, say Amazon Bedrock, push that into the search engine. All the documents come in. At the query side, the user enters some kind of text query, cozy place to curl up by the fire, and that goes to my chat application. The chat application brings both conversational context and semantic context to run a query to bring back information from the search engine that can help inform the generative portion of the chat. So LLMs suffer from hallucinations. LLMs are happy to make up anything they feel like. You can ask them, they'll make up an answer, right? The purpose of search within the context of generative AI is to bring the accurate information so that the information that the LLM retrieves is accurate for the result. So where are we headed? Will we ever get rid of 10 blue links? No, I don't think so. Honestly, if you're searching for the XJ57R4 connector to go from 1/8 inch to 1/4 inch, water piping, and you know that's the part number, you always want the ability to match lexically. But at the same time, we have this more conversational and chat-based interfaces that are making it possible to have that more conversational and meaning-based experience with retrieving information. So I'm going to switch topics now. I'm going to talk a little bit about Amazon OpenSearch Service and talk about OpenSearch. OpenSearch is an open source search, analytics, and vector suite that is provided as an open source project. Project, sort of by the numbers, we're approaching actually 800 million downloads now. We have thousands of contributors. We have all sorts of folks in the community pushing changes and working with the project. And in September, the project moved to the Linux Foundation under the OpenSearch Software Foundation, and we're tremendously glad to be part of that and to have open governance brought to the project itself along with our external contributors. With Amazon OpenSearch Service, we provide a managed service for OpenSearch. So it is managed open source. We make it easy to configure, deploy, and use OpenSearch in the AWS cloud. Of course, security is job one. We provide all sorts of security controls. OpenSearch itself provides fine-grained access control. We have encryption at rest, encryption in flight, and a number of different compliance that we adhere to. Search is the core use case. We provide lexical search, semantic search, knowledge base for RAG, provided through our nearest neighbor search with our KNN plugin. We support sparse, hybrid, multimodal, all the different kinds of semantic models that you might want to use. Our second kind of big workload is observability. So OpenSearch Service provides the ability to flow voluminous log data, bring that into the service, build charts and graphs on top of it to be able to monitor your infrastructure, your application, your business metrics, what have you. And we have a number of integrations with other AWS services, including DynamoDB, DocumentDB, and now with externally being able to query against CloudWatch and Security Lake. So our core workloads, again, search provides structured and unstructured search, again, with adjustable ranking, with user behavior capture and the ability to personalize search, suggestions, type ahead, and faceted search. In the analytics, again, we provide the ability to flow log data. You can build for monitoring your application and your security. You can build for observability, real-time dashboarding. It's cost efficient. We have a number of different ways to reduce cost by tiering storage of your data. And we have an integrated AI assistant that enables you to query with natural language against your log data. On the vector side, we provide semantic search, dense and sparse vectors, billions of vectors, tens of thousands of queries per second for both lexical and vector search. We have a number of different quantization options that enable you to manage cost for your vector workloads, trading off a little bit against accuracy. So OpenSearch is a database technology. You have your source data, you structure it as JSON, you send it into OpenSearch. OpenSearch indexes all of that data. All of the JSON fields are indexed. This is a contrast to some other database solutions where indexes can be limited, but OpenSearch is all about indexing. So we provide indexing across all of that. And on the query side, you send your queries as JSON requests. You get back a set of results. For vectors, what we provide is K-nearest neighbor plugin that gives you the ability to send in vectors and find neighbors in that large space. We support HNSW and IVF. HNSW is hidden navigable small worlds. IVF is inverted file. These are two different algorithms. And we support a number of different engines, including FACE. Oh boy, I'm gonna forget this one. Facebook AI blah, blah, blah. As well as NMSlib, as well as Lucene. We provide managed clusters. This gives you the ability easily to scale and deploy. And we have a serverless offering that makes it really simple just to use. We provide a neural plugin. This enables you to connect to third-party model hosts and automate the process of creating vector embeddings as you're indexing and creating a vector embedding for the query. And it supports lexical vector and hybrid search. So there's a couple of themes that come out in vector workloads. And I wanted to really highlight two of them to bring them to the fore so that you could hear from also how Adobe and Freshworks view these problems. The first of those is data preparation. So, you know, there's the old garbage in, garbage out, right? And you'll start with a document. And that document needs to be prepared for vector retrieval. So the first thing you might want to do is entity extraction. Whether this is with AI-driven entity extraction for like people or things like that, or whether it's looking at tables, pulling out values from tables based on columns to be able to query against that. You need to normalize the text. You need to clean any additional kind of user-generated gaming the system kind of things. You then want to do summarization. Perhaps you have images in this document. You run them through an image model or a multimodal model to pull out a text for like a caption or a description. You want to take big blocks of text and break them down into smaller pieces called chunks. If you think about it, if you look at a paragraph is usually a unit of semantic information. So a paragraph is a frequent chunk, but if you go across a whole document, you get too much semantic drift and you can't really accurately retrieve. So you really want to chunk into smaller pieces, and then you want to embed each of those pieces, build the vector embedding for that, before sending it off to OpenSearch service. So data prep is a little talked about piece of the retrieval puzzle. This usually wants to happen kind of in the background, offline. So it's very common to have some bucket, like S3 bucket, that has a set of source documents, and then a data prep kind of algorithm or data prep application that's going to go through, do all of that data prep we talked about, and then bring the prepared document chunks into a second bucket. With Amazon OpenSearch Ingestion, you have an auto-scaled pipeline that can read from an S3 bucket and deliver that data to OpenSearch service. And so you can build this offline processing mechanism to prepare your data and bring it into OpenSearch service. The alternate to this, I mentioned the neural plugin. The OpenSearch neural plugin provides you a way to build pipelines, both on the ingest and the query side, that can automate the processing of your document at index time and at query time. So we have an ingest pipeline here called remote neural pipeline. We define a set of processors. In this case, we're simply taking a particular field, sending it off to modeled for embedding, and then putting it back into so in this case, description goes to the description_v field. So it's that simple. You can just send your document in, OpenSearch will send it off for embedding and put the embedding in that field. When we define an index in OpenSearch, index is the main container. It's like a database table. So you define an index, you say index KNN true, you say which pipeline you're going to use, and then you have your field desk_v, vector type field. We have dimensions, we have the method HNSW, the library, like that. So you simply define your index, and that enables the vector search. On the query side, you have a couple of different query methodologies. You have exact query, where we support that with a script-based scoring mechanism. For exact KNN, you're comparing your query vector to every vector in the whole index. It's not particularly performant, which is why people do approximate KNN, but it is exact, and so you get the best accuracy from it. In this case, we have a query that filters for a particular range of values, the price less than 100, and applies the KNN scoring against the vector and with the query vector embedded in it. On the approximate side, again, approximate you run because exact is exact, but it's costly. So in this case, we have an internal filter. OpenSearch has what we call efficient filtering that's able to apply filters as it walks the vector graph that solves for a couple of problems when you post-filter. So in this case, we're just giving the embedding as a vector. We're saying how we want to filter it, and OpenSearch does the retrieval. The final method is hybrid. With hybrid, you run multiple queries concurrently and then combine them to get best of both worlds. The usual mode would be to run a lexical and a vector search and then combine the results for the best of both, right? In this case, we define a search pipeline. The pipeline defines the processors and the methodology for combining the vectors. So this is a hybrid query. We have a match query that says, find me red things. And we have a neural query that is a red shirt. Neural query automatically pulls the vector embedding for that query text and brings it in. You define this pipeline, this search pipeline, with a methodology for normalizing scores, because of course lexical scores and vector scores are in different scales, so you have to pick a normalization methodology, and you pick a combination methodology. So that's wrapped up in the search pipeline. So the second sort of broad theme that we're seeing is around evaluation, and especially trading off between cost and accuracy and latency. Because you can use quantization methods that will greatly reduce cost at the expense of accuracy. And you can go exact to have really great accuracy, but with high latency. So there's always this kind of golden triangle, if you will, of trade-offs that you need to make in this space. Really important, you're going to be, if you're adopting this technology, you need to figure out, is it working, and is it working well, and is it worth it, right? And so the first thing that is the key enabler really is the golden set. With the golden set, either with people or through running exact KNN, you develop a set of query result pairs that are the actual correct pairs. Then you're able to use an iterative cycle to test additional queries against the golden set. Actually, not additional queries. you're actually testing the same queries as you adjust hyperparameters of the model, as you make trade-offs for latency and cost. And so OpenSearch Service provides controls to be able to do this accuracy, latency, and cost trade-off. So I'm going to ask Abhijit to come up from Adobe and talk about Acrobat AI Assistant. Thanks very much.
Hey, thanks, John. So how many of you people have interacted with PDF? Kind of show of hands. So, and most of you would have wanted really quickly to get your answers when you interact with those PDF documents, and that's where Acrobat AI Assistant comes in, and we have been able to kind of provide that value. It's generally available for everyone to kind of go and start using. So Acrobat AI Assistant allows you to interact with PDF documents, and not just PDF documents, but other formats of documents across all the surfaces, desktop, web, mobile apps. You can ask your questions, and you get your answers with attributions so that you are confident of those answers. It will show you where the assistant is getting the answers for you. So this is a landing page for Acrobat AI Assistant. You don't have to log in. You will just get the experience. You have a document there. You'll be able to quickly get to see how valuable that experience is. And as with PDF documents, we have a core engine that we use to extract different components of those PDF documents, text, images that we use to kind of ingest in for our LLMs to create the context that we send to the LLMs for inferencing. This is a core engine that we use, Adobe Extract. It's also available for everyone to kind of use. You can build your own solutions on top of the Extract API. So this is how Acrobat AI Assistant kind of is on Acrobat Web and Desktop. On the right-hand panel, you have Assistant. You ask your questions. When you get the answers, you have the attributions. When you click on those attributions, on the left-hand side on your original document, you will see all those attributions. Within a bounding box, you'll be confident of whether the answer is right or not, and the LLM is not hallucinating, kind of following Adobe's policy of being responsible for AI. And this is our Acrobat PDF Extract API. You see on the right-hand panel the JSON that we have extracted. It runs a lot of background processing on our servers. These APIs are available. You can build your solutions on top of it. We have built our Acrobat AI Assistant solution on top of it. You can see the bounding box of various elements. You'll get to know which one is heading, which is an image, what is a paragraph, what are the different semantic elements in the document. And you can kind of, that is the data prep part of your solution. You extract all the information, you massage it, you clean it up, and you send it to the LLM for getting your answers. So as John shared, there's a lot of requirements in terms of finding out the attributions, and you really have to work with a lot of embeddings. The embeddings help you kind of get to the source of the document for the answers. That's where we have been leveraging OpenSearch. So at a high level, we have two main workflows. One is ingestion workflow. Ingestion workflow kind of works with you ingest your document into Acrobat AI Assistant. In the back end, within few seconds, we make that available for you. You don't have to wait long. Most of the documents are available under a second for you to interact with. Behind the scenes, we convert the PDF into a JSON. From the JSON, we extract all the chunks. For the chunks, we generate embeddings, and those are stored in OpenSearch. And as soon as that session is available, users can start interacting with our assistant. So once the ingestion has been completed, we want our users to kind of start interacting with the document, start asking the relevant questions, and get to the work that they really want to do. So this is a very high-level overview of our pipeline. You'll see the user inputs the question, we get the right content from our system that we need to answer that question. We send it to LLM, we get inferencing from LLM, the answer that we get. We have an attribution engine that breaks it down, tries to find out the right source on the original document, and that's where we use filtering, efficient filtering from OpenSearch. We use different similarity scoring mechanisms that are available. And of course, we are not limited to one embedding model, so our vectors are of different dimensions. We support languages, and we are multilingual. Our assistant is multilingual, so all those capabilities and flexibilities are available to us through this vector DB. So I just want to walk you through the scale and the functional requirements we have with OpenSearch. We wanted to build a solution that's available to our hundreds of millions of users who work with hundreds of PDF documents, millions of PDF documents, and we wanted to really make sure that it scales. And we wanted our users to kind of get to their work within seconds. So the indexing workflow couldn't wait, it couldn't be batched, and that's where we were able to kind of get the indexing part down. There was a scale that we were looking for, and the solution overall had to be cost efficient, and that goes back to the triangle of trade-offs between cost, latency, and accuracy. So once the indexing is done, we are also looking forward to the attributions that we generate. And for that, OpenSearch ticked all the boxes. It was able to handle vectors of different dimensions. We were able to create indexes. We were able to get the right embedding, apply the right algorithms for similarity search. And it was able to support the throughput that we were looking for. So our use case is a user comes in with their document, interacts with it, gets the answers, and gets on with their day. And that means that we don't have a static knowledge base that we can take our time to index and make it available. So the indexing has to be on the fly. We want that indexing to be in near real time. And we want to power our attributions using that. So, and that brings us to an interesting problem. We don't want to store the embeddings for a long time, because once you have interacted with your documents, you don't really stay there for a very long time. So we started using rolling indexes. Because of the transient nature of our embeddings. So every hour, we roll over to a new index. Any document that's opened during that hour is indexed into the active hot index during that time. And that's how we kind of control our costs. And this index is deleted after 12 hours, so that's another cost-saving mechanism that we have put in place, and it also effectively helps us query our answers quickly. So another advantage that this brings up is we are able to kind of upgrade, migrate to a new embedding model, or scale up our OpenSearch without our users facing downtime. So this is the transient content in OpenSearch. Like we talked about, you interact with your document, you move on, and that's really helped us. And the hourly rolling policy is also something that we have been, which has been very helpful for us. And at a high level, these are some of the numbers. Of course, we have all, with the scale that we are working with the new features that are coming in, these numbers we have already crossed them. So I just wanted to give you a glance of the scale we are operating with. Millions of embeddings, huge, significant size per embeddings, the number of indexes, the shards that we are using. This is spread across, so another advantage we have is we are spread across region. We are able to support data residency for different regions if and when needed. We have a huge amount of requirements for, because of the speed with which we need our querying and indexing to happen, we use a lot of memory and compute, and that's how we have kind of provisioned our shards across the different available regions. So these are the throughput numbers. These have been increasing significantly, and we have kind of met and kind of exceeded these throughput, and we have scaled up multiple times. And that's always been a pleasant experience with no surprises for us. Our indexing and search latencies have been manageable, so that your experience with interacting with your document is not hampered by how slow or how fast how slow the system responds. Yeah, that's about it. Thanks. So we'll have Shri join you guys.
Awesome. Thanks, Abhijit. Hello, everyone. This is Sridhar Gade. I lead cloud engineering and responsible AI at Freshworks. We spoke about the product itself, OpenSearch. We also spoke about the document search implementation from Adobe. Over the next 10 to 12 minutes, I'm going to walk you through a little bit of under the hood architecture and thought process on how we implemented OpenSearch at Freshworks, especially as we are trying to transform our customer experience using generative AI applications, and how OpenSearch is at the heart of our entire generative AI strategy. Before we do that, I'm trying to get a little bit philosophical, because I think after a few years, when generative AI is going to take over most of the human actions, I think we'll have a lot of time to introspect on our life and purpose and everything else. Think of this as a little bit of departure into that, right? So historically, humans have always kind of in a search or pursuit of things, right? And that's what, step one is kind of seek the purpose, seek the intent. And it's always been conversational, right? Since the time the speech has been invented. But in the advent of computers, we spoke about filling the forms and opening tickets. But at the end of the day, it's conversation. So after that, once you find what you're actually seeking, the finding is the toughest thing. There's a lot of interpretations. The language, intent, what exactly do you mean, and many other things. And that is actually the complex part, which is actually trying to solve through OpenSearch. And then once that is done, we are talking about actions, right? We don't want to stop at just finding things, but also the making things happen so that the loop comes back to you with the fulfillment. So this is, I think, overall philosophy of the search that we are looking at, and then and I think that kind of finds the entire analogy of our philosophy behind building our entire search platform. So before we jump into the exciting architecture at Freshworks, I'll talk a little bit about Freshworks as a company, so that way you just understand what type of organization it is and what about challenges that we are facing, so that way you'll be able to relate to where you are today. Right? So Freshworks as a company has been around since about 14 years, and we have close to 70,000 plus customers. We're close to reaching $1 billion revenue in next year or two. But one notable thing to remember is Freshworks is the first software SaaS product company to born out of India and go public in the US. Okay. Thank you. And we had quite a journey. When we started, Freshworks as a single product company, and that is in customer experience journey. And as most of you know, one of the, I think, the largest or the biggest problem we are trying to solve using generative AI is also customer experience. So, but then over time, we started adding more and more products as we evolved, and to enhance and add to customer experience. And then we added employee experience suite of products as well. And then, like you can see, we also started our generative AI or AI journey about 6 to 7 years ago, sometime in 2018 times. We started playing with the BERT, our basic models, started training the ML models with our data. And then once the GPT wave came in, like 2 years ago, then we actually started writing that. And we're proud to say that we are way ahead of most of our competition in terms of how are we using multi-agent framework and vector databases and action framework for us. So that is a little bit about Freshworks as a company. So now let's quickly jump into the agenda. So in the first section, I'll quickly look at the use cases that we are trying to solve, the challenges that we had historically, and then how we went ahead and solving them. And the second part is I'll take a little deeper into architecture and the strategy that we used in terms of how the whole, the plumbing of the under the hood structure. Then we also talk about a little bit of scale, because Freshworks is all about scale. We're talking about trillions of metrics and petabytes of logs, so you can look at that as well. And then we'll wrap it up with the next steps, basically feature state. Right? So before we get there, so let's say the use cases at Freshworks, right? The standard use case you can all think about is the lexical. So historically, all of our products, the home page, the search pages, everything is kind of powered in the backend by OpenSearch, because we are talking about billions and billions of reads and writes. We have customers in close to 120 different countries, and we serve pretty much in 45 different languages. So when you're talking about the scale, the expectation is that the responses are real-time, relevant, and predictable and secure every single time. And that's exactly what we do with the lexical. But then we also, with the advent of generative AI coming in, we had to also start looking at the vectors, where you look at the multimodal data sources and see how do we actually implement the semantic search. And semantic search is actually started helping even in the non-AI use cases, because then we started feeling, and especially it kind of brings together the multimodals, so it becomes a lot more easier for us to actually get a much better the relevance. So last but not least, observability. So observability at the heart of Freshworks strategy. So we have in homegrown Grafana and OpenTelemetry based observability system that is built like in full stack, both with the synthetics, infra, application, APM, and everything is kind of inbuilt. So we're talking about close to 300 terabytes of data collected per day, and also probably 50 TB of traces, and then also metrics. So we're talking about trillions and trillions of metrics are collected every single day to kind of capture customer behavior at at every single step. So all that is fed into OpenSearch, and then we do all kinds of analysis to make sure that all the triggers are kind of identified and addressed. So these are the broadly top use cases that we are trying to solve. So, but then I'll talk a little more deeper about two major ones. The first one is, so let's take an example of a Freshservice. It's an ITSM product we have in the IT employee experience place, and our customers essentially, when they have an issue with an IT issue, or you have an issue with an incident, they actually open up a tickets. So for the agent who's actually looking at, agent needs help to solve the problem, and every single time, it's a cause and effect, but the customer always knows the effect part, right? And they not necessarily know what is happening under the hood. So for a particular cause, there could be 10 different type of interpretations that customers have. So it comes in a different formats to the agent, and it kind of tends to confuse them. So here, using semantic search with the nearest neighbor, we look at multiple different attributes and then try to suggest, here are the top 3 types of incidents which are very, very similar, and here are the solutions that are available, and then agent can actually look at them and quickly resolve them. So this is a very basic example, but I think you can go all the way up to prediction of the incidents and self-healing of those incidents, and even the prevention of incidents as well. The second one is more cooler, the generative AI use case. So generative AI we are using in 2 areas in Freshworks. One is to help the agents to enrich their experience and the knowledge or the access to knowledge that they have. So we call it co-pilot. So if the agent is actually trying to understand exactly, it just came into a shift, and I would like to know what's going on with this particular customer. So the co-pilot can go and look at the last 3 months of history with that particular customer, and then give you all kinds of analysis to help them succeed. But then the second part, which we are going to talk about, is actually the autonomous agents. So agents is more like a self-service experience where you do not hit the human agent. You actually hit the bot, and the bot basically knows everything that is there to know in the customer service or the IT space. And then basically you interact with the bot. Bot will try to, one good example is, I'm trying to actually get to my HRMS, like say Workday, and say, hey, I would like to apply leave between December 20th to January 3rd. And then basically it needs to look at the Workday system, connect it, understand your leave balance, and then go ahead and actually make a connection and trigger the action of applying for leave. And that is a simple example, but it could be as complex as giving refunds from your customer perspective, or even actually doing a complex travel booking, which includes flights, hotels, and looking at various different dates in terms of the holidays, layovers, and everything else. So it is happening today as we speak. It's not a future state, it's a current state. So this is another area that we are actually fixing using this. So let's get the under the hood, what's going on under the system. So essentially, what we did is we wanted to actually think about, hey, this is a scale we are looking at. We are just getting started. We are talking about 1 billion revenue, but then we might go like 10x from there. And also, we are already covering 120 different countries, but then we want to vertically grow in each of these places. The language support is there, and looking at all that, we said we want to build something for future. And that's exactly the reason why we chose Lucene. It's like a high performance, like a full featured search engine. One of the reasons why we chose it is essentially it does filters very well, and that is the fundamental to our product, because customers actually work with a lot of different attributes and filters, and whether it's a pre-filtering or post-filtering, it's very, very useful. So that's one of the reasons why we picked it. And then when it comes to algorithm, we are looking at it's a HNSW, where multi-layered. So looking at depending upon whatever nearest neighbor for sure, but then whatever you can find quickly, and then the speed is prioritized over accuracy, as long as accuracy is beyond certain percentage. And then as you can you're aware, L2 space is the underlying algorithm or the method. So this is the overall architecture-wise in terms of what was the thought process internally, right? So essentially, when we go a little deeper, we are a multi-product and a multi-tenant company, like I said, and so product has a different VPC, its own domain, and communication of that product going on completely differently. But then we are also using some kind of centralized approach for our VectorDB architecture. So they kind of pair with the VectorDB, and then the moment the request hits the VectorDB, so we kind of use Kinesis, Amazon Kinesis, to do the streaming part, and then that hits the embedding model. So we kind of centralize the embedding creation across the company. There are multiple products, but we thought we should do it centrally, so that we use the same methods everywhere. People do not need to reinvent the wheel. So it is the embedding model. Embeddings are created. It is again streamed back to VectorDB. So this happens centrally, and then whatever you see on the left side, which is a product VPC, you could think of that there could be like 10 different components of 2 different the product lines we have, which is employee experience and customer experience. And here I'm just taking you like 10,000 feet higher, so just so that there is a lot more clarity in terms of what we do. So the user query goes in a super conversational way, right? Absolutely no context and absolutely no background. And the user, when sends it, then first it is fed to our Freddy AI. Freddy is our brand for generative AI suite of platforms and products that we have within Freshworks. So Freddy sends it in an LLM that we are using under the hood. It gets the intent from there and then actually feeds it to something called our hybrid search, unified search broker or the load balancer. And then unified search kind of branches this search into 2 different, like lexical as well as semantic are simultaneously triggered, right? And then when the response comes back in 2 sides, so you look at the relevance, right, based on the scoring, and the final result is kind of given back to the unified search broker again. And then unified search broker talks to generative AI just to make sure that we respond back in a similarly conversational manner. So all this should happen in a sub-millisecond latency, and at the scale we are talking about, thousands and thousands of customers are actually using it, and that's where the design and that's where the best part is. So we started this journey about probably a year ago, and then we started improving. So we looked at multiple different. We looked at Pinecone. We looked at various different VectorDB databases, but we kind of stuck to OpenSearch, especially because of scale at which we are growing and where we can actually grow from there. So in terms of the footprint, I spoke to a little bit of some numbers slightly some time ago, but I think we are talking about billions of writes and reads. And like I said, we are just getting started as a company. There's a lot more to do. And so here, and then we are talking about like 2.5 billion reads. But more importantly, we have close to 700 different, 700 nodes under the hood for like an open search. We do close to 500,000 RPM as well, like across the board today as we speak, right? Also, right now in our central database, we have close to 150 billion documents, right? That's the scale that we have. So, and also historically, I'll also a little bit talk about what it was before, open search, so you'll be able to actually connect the dots. But then from the previous Elasticsearch solution to today, we have like at least 30+% of improvement in overall accuracy as well as the performance and latency, right? So here are the problems, right? How many of you still use Elasticsearch? Okay, so few names up here. So we did that, and historically we used that, I think, until a few years ago. Suddenly Elastic decided to go commercial, and then we were stuck. So is this the right solution? When the licensing changed, then we started doing POC with the multiple different vendors, and then we kind of found that, okay, this is where we want to put our bets on, and things will start actually really working out for us. So especially, I wanted to have this slide just to show you what are the different benefits the moment actually we move to the open search, right? So latency dropped out by half. Like we have nodes reduction, which is definitely money on AWS. So we are talking about searchable snapshots, hybrid search, and then cost savings. Like who doesn't love savings, especially in the current economy and in the world? So everything kind of came as a package for us, and we love to continue to scale this to the next level, right? So that brings there's one last thing. So basically, since all of you, I think like we spent some time talking about search and open search. So here is you might want to save this QR code where we are giving away 3 months free trial for all of Fresh Service product, which is ITSM, and you could go play with it. All of our generative AI solutions on the ITSM product in terms of how do we predict, detect, and resolve change, problem, and incident management through Freshworks. All right. So where are we going from here? And here are the use cases that we are going to actually solve going forward. Is think about this scenario. Fresh Service, for example, has 10,000 customers, and these 10,000 customers across the world have different IDPs, different document sources. Like someone might be using G Drive, OneDrive, SharePoint, and they also have a different language support. So, but when the user, their customer or their user is actually trying to ask a question, a conversational question, I want to be able to go and search in these thousands of different data sources that are available, and then be able to bring back those results in real time, right? It's a very hard problem. Especially, you'll not be able to predict the latencies, you'll not be able to predict the integration challenges between all the different data sources, but that's the exact problem that we are trying to work with Amazon. We are working with Microsoft and multiple different hyperscalers to see how we can actually track this, because the answer that you get to the query is only as good as the data sources that are available to you. And we want to expand that data source infinitely as long as the folks want to do. So the next one is the action framework. Everyone talks about retrieval, so search does a great job there. We bring the information from federated sources, multiple different sources, and bring it all together in real time, so user does not know where all we had to travel to get that information for them. But then how about actions, right? So this year, or at least last couple of quarters, has been about action frameworks, but then you want to do actions in a safe and secure manner. So imagine that there is a bank application or the travel application where action goes a little wrong, and then you actually end up booking the wrong flights or wrong hotels in the wrong days. This can very much happen. And that's one of the reasons why safe actions and guardrails are very, very important. That's the next thing that we want to build. But last but not least, yesterday or 2 days ago, Swami was on the stage in the keynote and talking about multi-agents, where how do we find free food and reinvent multiple different venues. And then there are 5 agents working in tandem together. You give them the purpose of free food, and they actually go and figure out and then actually tell you, they actually make a booking for you, right? So that is the present again. So this is exactly what we are building on our products where there could be 10, you just share the purpose and then 10 different agents will actually come up and they work in tandem as a single team and then give the solution that we need, right? So this is what I wanted to share from Freshworks story. So thanks for being a great audience, and I'm handing over to John.
So I just want to thank Shri and Abhijit. Thank you so much. So just as a quick wrap, and coming back to the basic search story, I think these two use cases, these two workloads that we've talked about today, the ability to interact with longer documents and interact in a way that you can ask questions and bring that information back along with attribution is one of the kind of core workloads that we see today. Second one is the chat and in the helper, the assistant, as shown by Freshworks. So even today, we're becoming more conversational, and those are examples. And the retrieval is really more about the meaning than it is about lexical matching. Again, finding relevant portions of your document, support for representatives, finding the right products to buy. These are where we see generative AI and semantic search really playing a deep role. It's all improved by AI models that enable you to bring meaning to the interaction with your information. So that's all I have. Thanks very much. Really appreciate your participation today.